So let us see this question. This question is saying earthquake magnitude R are measured on Richter scale, which is a base 10 logarithmic scale. Earthquake magnitude are measured on Richter scale. See, R is basically on your Richter scale, right? So suppose earthquake magnitude is X. Suppose. But we are representing it in terms of Richter scale. And what is the Richter scale R? It is the base 10 logarithmic scale. So it should be log base 10 and we have to take the log of the earthquake magnitude, that is the X. And we may have some other multiplier in this function. We can assume this as a k. So we can assume that my Richter scale is just like r is equals to k times log base 10 x, where x is the earthquake magnitude. Is it okay? Now, please analyze this logarithmic scale. I think we have already discussed what is the benefit of log scale. Why we use the log scale? Do you know why we use the log scale? What is the benefit of using the log scale? Do you know?
No.
See, log scale is very useful to study, to analyze very large numbers or very small numbers. Suppose you have to analyze a frequency response. Suppose you have to analyze a frequency response of a mobile phone. Mobile phone works on megahertz frequency. Suppose 950 megahertz, right? You are analyzing the frequency response of this mobile, receiver. So if you plot it, so what will happen? See, if you have a linear scale, suppose in on the x-axis you have the frequency, and in the y-axis you have to plot its magnitude of the signal which is received, which will be received on this mobile phone. So if you have the linear scale, do you think that you will be able to plot this 950 megahertz on a simple notebook or a simple graph paper? Is it possible to represent 950 megahertz if you start from the 0 hertz? Is it possible to represent this number? No. So
No.
for that, we have the log scale. Please see. You know the basic properties of the log, I know. See, log base 10 and 10. What it should be? Do you know the value of log 10, 10? It is
What one?
1. Very good. Now, if you have log base 10 and 100, do you know what it should be? It should be
Ten.
log 10, 100 can be written 10 squared, so it should be 2, right? Similarly, if you have log base 10,000, so it is the 3. So now please see, if your value gets 10 times, see, 10 to 100, it is the 10 times. Your value increased by just 1 unit. It is not the 2 times, it is just the one increment. You can see, you can verify here. If your value gets 10 times again, see, the value of log will increase by just 1 unit. It is not the 2 times of 2. Is it okay? Are you getting? So see, this 10 to 1000, that is the 100 times, gets represented by just increment of 2. So in this way you can represent a very large number with the small in a small scaling. Is it okay? Are you getting little bit?
Yeah.
Okay, so now see the same thing. This question is also saying the earthquake magnitude R are measured on the Richter scale, which is a base 10 logarithm scale. Relative comparison are useful. For example, an earthquake of magnitude R is equals to 4. Now, it is saying, suppose this is 4, is 10 times as stronger as an earthquake of magnitude R. So, for R is equals to 4, we should write R is equals to K log 10. Suppose its value is x1. Similarly, if we have the Richter scale 3, see, if we have the value 3, it should be K times log 10 into x2, isn't it? Where x1 is the magnitude corresponding to this 4 and x2 is the magnitude corresponding to the 3, right? If you
Mm.
divide it, see, if we divide it, what we will get? So suppose this is the equation 1 and this is the equation 2. So see, just the increment of 1 unit, you can see the increment of 1 unit is 10 times, as we have discussed here also. See, if you increase your x value by 10 times, there will be increase by 1 unit in the log value, and that is the same thing here also. Are you getting this?
Uh,
Now it is saying that what is the magnitude of an earthquake R1 that is twice as stronger as the another of the magnitude R is equals to 3. So now we want to find the Richter scale for an earthquake whose magnitude is twice as stronger. So it should be k times log 10. And what is the magnitude here? It is twice as strong as the magnitude of R. So see, for R is equals to 3. So for R is equals to 3, I have assumed as x2. So it means here it should be 2 times of x2. Are you getting this? This is the main step. This is the main step of my explanation. Why I have written here 2 times of x2. Are you getting this?
mm,
Because the question is saying, what is the magnitude of an earthquake R1? It means we are looking for this Richter scale value. That is, it means it is talking about the magnitude. The magnitude of R1 is twice as strong as the another of magnitude R is equals to 3. So for this R is equals to 3, whatever the magnitude, that was the x2. Now the magnitude is twice of the x2, so we have to find this log value. Is it okay? Are you getting this?
uh,
So how we can solve? So, okay, we can apply the log property. See now, for the time being, I'm ignoring this k. So if we apply the property of log, can we write this simply log 10 2 plus log 10 x2? Is it okay? Do you know this log property?
oh, yeah.
If you see, this is a property. If you have log any base 10 a into b, so you can write log 10 a plus log 10 b. So can we write using this property?
Mm,
Now we have the value of this log 10x2 is 3. We have this 3. We have given. So it means we have given this value as 3. Now this is a constant. This is a constant. You can calculate this value using the calculator. This is a very standard value. Log 2 is, I think, 0.30 something. Please write it, then I will explain something more. Log 2 10. Please find what is the value of log 2 with base 10. Right? It is
mm, 0.3.
0.301, right?
Mm,
So what you will get? You will get 3.301. That is the value of R in the log scale. If the magnitude is twice with respect to 3, then you will have the 3.301. Any doubt, any problem?
no.